Good morning, ladies and gentlemen. So, as I mentioned, I'm from Sandvik Mining and Rock Technology. We are partner in the EIT material as well. I am involved in some project with an EIT raw material. So, what I'm talking about is about eco-efficiency in mining, which gives you some idea about the eco-efficiency and mining activities, mostly focusing on the comminution, which is the most energy consuming part. I normally start with a glance on mining industry. How big is the mining industry? It's just some data from the mining industry. What is about? We are totally producing about 17,000 million tons of the raw materials. The total value was $1,400 billion. But if you're just looking at the mining, metal mining and mining part, is excluding the fuel, is about 2,400 million tons, with approximately 700 to 800 billion dollar of the income for the mining industry. And if you look at the investment, what is the investment in mining industry? The investment, as you show it was very high in 2012 because of the booming time. But you can consider about 120 billion dollar per year as a basic or sustainable investment in mining industry. So if you are a company, you can actually build your expectation based on that. Every year you have about sustainable 100 billion to 120 billion dollar investment in mining industry. We are a major user of the energy in the world. About 70% of the total energy in the world, it goes to mining industry. And this is from mining up to the end of the process, not even metallurgy, that one, 7%. And from that, about half goes for the comminution. That's why comminution has a tremendous role in actually energy consumption, and we are looking for that one to reduce it. This shows you how the distribution of the energy consumption, and as you see it here, 40% is just going for the milling. Milling means that actually having fine particle for the process. And total in comminution, which is milling, crushing, and even blasting, is about half, is almost 50%. So it means that 2 to 3% at least goes for milling in the world energy consumption. This is direct. And indirect, considering that you are milling the product, you are using the media in the mills, balls, or some medias for crushing and grinding material. For each ton of this metallurgical steels, balls production, we use about 6 megawatt energy per ton of the media. So this is indirect, but it's a huge. And considering that in each process we are using about 0.5 to 1 kilogram per ton of this media. So you see how big is this as well. And unfortunately, the energy efficiency in grinding is very low in ball milling and in tumbling mills, which is usual. So it's about few percent. And most of the cases they are talking about 1% energy really goes for the real grinding, but we consider a few. So that's why it's important to look at it carefully. So if you look at the mining industry and the kind of the problems with the mining industry, and mining industry has a problem, one is actually declining the ore grades. So during the years and years, our grade is going down. So we need to produce the same amount of the final product. We need more throughput, more material extracting from the mine, going to downstream. So the complexity, which means increasing world demands, one is the complexity, environmental legislation, more and more coming to the consideration, water limitation, social expectations, energy and cost for the energy and availability of the energy, and carbon taxes. These are the complexity within our industry, directly with the production. Productivity improvement, balancing talent requirements is very important. That the balancing talent requirement, this is part of the EIT raw material to do it. because we need good engineers, good workers, good technicians, all. Capital dilemma, resource nationalism, price and currency changes and volatility. Another one which is important, we are talking about that more and more digitalization and control over with this kind of things with computer and having the center for controlling everything. Cybersecurity is very important. Last summer, Barrick Gold, which is one of the biggest gold mine production in the world, they had a problem because some hackers went to their system and they had few months to fix it. They need a few months to fix it. And this is cybersecurity. Even we are going more and more toward digitalization and control, automatic control. You can do mining control with your actually mobile phone nowadays, but it should be security for the cybersecurity is very important. And capital of the project. So these are something that I just said. If we look at the mining and sustainability, so these are the kind of elements for sustainability. Energy, carbon footprint, rock characteristics, grade of material or resources, grain size of the resources, and the water. If we look at it, since we are dealing with the harder material, we are dealing with the lower grade material and other things, so we are against this sustainability. Mining and sustainability is a paradox. What happens that keeps us sustainable is the demand. Because the population growth, then we need the demand. So the demand keeps us sustainable as a mining industry. But looking at these elements, we are not sustainable. That's the case. So we are trying to be more and more efficient and sustainable based on the reducing the energy consumption and also the water consumption and other things. What about the eco-efficiency in mining? Eco-efficiency is actually the product or services that you are providing with kind of environmental influence or environmental factors. That's defining as a eco-efficiency. And in general terms, the eco-efficiency is aimed to reduce the material intensity, reducing energy intensity, reducing dispersion of toxic substances, enhancing the recyclability, and also maximizing the use of the renewables, extend product life, and increase service intensity as well. So these are also eco-efficiency definition that we in mining industry have to follow that if we want to be more and more productive and more kind of sustainable during our production life or something. And this is also shows you how to do that. It means that eco-efficiency is not just because of only saving energy, it is total, because you have to look at also the just making money or not. No, this is a total consideration of the environmental and also social aspects as well, and looking for this circular economy for human progress and also well-being are the mechanisms for that sustainability. For that one, we have to look at the whole process as a beginning of the mine to the end as a one scenario and try to have better production, more efficient mining system, efficient processing, manufacturing, and also recycling as well. If we look at the Convolution, competency is increasing, that is some assumption, by 1% per annum during the last few years. And that right side figure shows you our ore grade and how, this is for copper ore, but how much energy we need to get the product based on the grade and also based on the size that we want to be. 5 micron, 10 micron, 25 micron, 75 micron, based on the size that we want it, we have to go down to liberate values and to do the process. So that's the case that you see that tremendously the energy consumption goes up. And that also shows you how, again, energy consumption with the final product for the process after the comminution, or after the comminution in general means size reduction. So that's the case. That future, we are in the range of 10 to 100 micron at the moment based on our resources, but in the future we should go up, and then you see that this the figure exponentially goes up, the energy needed for that one. This is also shows you Sandvik mining and rock technology. Of course, this Sandvik is not just mining and rock technology. We have material, we have machinery, and so on. But anyway, this is how we are working. We are working from the face of the mine up to the milling, and that's our business is stops. So this is what we are looking at, a whole scenario. We are trying to look at the whole scenario and connect all these steps from the exploration, exploitation, material handling, input crushing and conveying, as well as the comminution crushing, to look at this one scenario to help mining industry for better and for the sustainable, to be sustainable. So I mentioned about that comminution and the energy. So that's very, very important for us, and this is again showing you how it's important, and is about 50% of the total energy goes for that one. But comminution starts from the blasting, and if we have a good blasting in the mining, we can actually have kind of better process and better efficiency in resource utilization. The right-hand side shows you some comminution, some blasting, that the size distribution is exaggeration, but size distribution is narrow. So it means that is good for the transportation and downstream comminution. But if we have kind of SAG or AG milling, which means semi-autogenous and autogenous, which is trying to get big particle and small particle to help in comminution, you need the left-hand side comminution. So that's why the comminution is important, or blasting in comminution is important. Playing is important role. And the comminution, the blasting is the most efficient comminution process from the energy point of view. But it costs a lot when you are doing that one. So this blasting affecting the mining, affecting the load and haulage, affecting the grinding and process. So in a way that when your mining, your process is affecting as well. So you have to find a way that all of these factors means that blasting, grinding and crushing, digging, and also the process would be together in a one scenario that you have the optimum amount of the efficiency for per ton, means that you have to use the blasting effort in a way that you get this kind of optimized section. So this is why you need to have good characteristics of your ore, and then combining all together, looking downstream, looking upstream, and combining together, and then having that one as an example. Normally we are doing the blasting with the power factor of the 1 or between 1 to 2, means that the amount, the gram of the blasting agents compared to the tonnage of the material that you are extracting. And nowadays we are going toward the higher. In this case, we reduce the energy consumption in milling, and we increase the tonnage for the throughput, and then also environmental aspect with having a better blasting pattern, better blasting. So potential reduction of 15% in energy with 30% increasing in the throughput is possible if you have the smart or good blasting pattern. Here also shows you the different things. So it's increasing by increasing the powder factor, you can actually have the better kind of comminution and less energy from 33 kilowatt hour per ton to 28. And then also you can actually do it in a smart way for selective blasting, which means that you do finer blasting in the process. You don't have this, no, laser. So in the middle that you have high grade material, you can do the blasting, higher blasting there, and then finer blasting there, and then coarser. And then you can actually have some kind of better material in the middle, as you see that this high grade material. So this is also kind of smart blasting, and then you can use just for some kind of primary screening or something, remove part of the material that you don't want to, send it to process for the grinding, which is lots of energy consumption there. This is showing you. So this is the high grade in the left-hand side, medium grade, and then you can have such a kind of size distribution. And if you put some screening in 200 millimeter in the right-hand side south, you can have about 90% of your material with removing of 50% of waste in just one screening. A very simple one. But it should be smart, and you should characterize your ore very good. After the blasting or something, classification is very important. How you do classification? Classification can be different from screening, hydrocyclone, cyclone, and also spirals, classifiers. And this is very important how you choose it and how you work in that. We had a just as an example, we had a project with the Peru, and they had 3 rod mills in open circuit with the 3 ball mills. 1 ball mill went off, and then they want to have the same kind of production with the 2 ball mills. So we changed the classification from the hydrocyclone to screen classification, very efficient. We could have the same kind of production with 1 ball mill. 2 ball mills went up. So that's a tremendous reduction in energy consumption. 2 ball mills went off with the same kind of production. So this is how shows you the classification is important. So what we needed is instrumentation and measurements control, process optimization, efficient sizing and classification, bulk and particle sorting when we are looking for the whole scenario, energy efficient comminution, and then also material engineering to develop material engineering and material development. We are also part of that because Sandvik has this material. We can have better material for wear and for the rock tools and so on and so. And then also forming and developing expert teams. That's very important. Expert teams. We need expert teams in different areas to help the people in or mining industry in a better way. I was talking about the water issue. Just water comminution and processing is using a lot of water, and our access to fresh water is decreasing by years. If you look at it in the beginning of this century or 20th century or mid-20th century, what 4,000 cubic meter per person per annum, now is 1,000 cubic meter. So that is important. And water, and not only we are also using the water, we are polluting water because of the releasing of the different kind of ions to the water. So this is important. In the process, for example, the water consumption goes up by changing the grade of the ore. For example, if you want to produce 1 kilogram of gold, you need 500 cubic meter water to use for that 1 kilogram gold. So that's very important of the water. And then we contaminate water. We need to recycle the water. We need to recycle to purify the water and so on. So these are the issues. And another thing, we need water when we are using energy, because we are using different energy, renewables or oil or whatever it is. In the refining of them, we use water. We have to choose also the energy our energy source to use as less as possible the water. In this case, actually, we are looking for the mine-to-mill optimization concept, which means that maximizing system throughput through the mine to the mill, and also looking at whole as a scenario. Developing of accurate throughput forecast model by understanding the impact of the ore type and the blast on blasting and other things and processing, and also reducing the energy consumption and greenhouses at the end. So we have to look at it as a scenario. Before, normally the mining industry looking at the, exploration as a one silo, mining as a one silo, processing as a one silo, and then others as a one silo. Mining engineers, they want just to produce 50 million tons, just leave it. It's not enough, because the process engineers need some kind of quality, some kind of understanding of the material. So it should be a whole scenario. That is why what we are going to do, a holistic approach. Mining activities to design are designed to supply proper feed for the downstream. We look at the exploration side with measurements while drilling, better blasting pattern, and which is helping all the way to the process. And that's the case, which we are looking for. And this, I show you activities of the Sandvik, but we are trying to connect all of this together. For example, from the drilling point of view, with measurements while drilling, when we have the both chemical and physical characteristics of the ore as much as possible, then we can use bulk sorting. We can use mucking control measurements while mucking in the mine, bulk sorting, particle sorting, as well as new generation of the crusher and comminution devices, comminuting, assisting technologies, and everything to have much more control over the material coming from the mine side to the mill. And that's part of my job in Sandvik to do, and to connect these different kind of blocks or different kind of business areas in Sandvik. So we have a program in Sweden. We call it, I was part of that also, a smart and innovative mine of future. The aim is actually by 2030, we reduce energy consumption by 30%, waste by 30%, and so on, so on, so. And this is what we have to do. Good resource characterization, good mining planning, less dilution, selective mucking, bulk sorting, good milling to feed to milling, and then control mills to have the less kilowatt hour per specific size of the production, control feed over the processes, and control the flotation and higher recovery at lower cost. That's the aim of this kind of program, Smart and Innovative Mine of Future. And this is also part of our job when we're looking at the mine. This is also part of ideas that we gave it to the BHP Billiton. So from the mine, from the drilling part, this is, you can see sense. We need the sensors to understand what is going on, and then material handling, and then we have great control over the input crushing and material handling. So we need also sensor to actually to sense in the upper part you can see actually the blasting pattern. So these are the blasting part. So we need also to sense that one as well, to sense what the material coming and what material goes to for the process. And after that, with great control, we can go to the process plant or downstream. This also shows you if we have a good understanding of our mine and then doing the measurements while drilling and something like that, then we have actually better block modeling of the material. Then we can use some kind of bucket or on convey bulk sorting of the material and then going to the process as well as this one. A smart implementation of current technology is needed while we are considering uptaking from the future technology. So we have to be flexible. When we design the plan, we have to be flexible. We have to be smart enough to use We want always homogeneity, but we cannot get it from the nature. We have to use the heterogeneity in the best way. We have to be flexible. This is just show you about that, an example of the how systematic approach for the measurements while drilling. So you have, if you have a precision drilling and control, then you can have actually better blasting, better understanding of your ore body, and then better blasting, better material handling, and then going down to process as well. So that is some kind of example of the approach. This is what we are looking at the moment for that one as well. And except that, we are doing some characterization optimization feed size for the comminution and best comminution circuit, energy in liberation, waste removal, more efficient equipment, measurements and monitoring in different stages. Digitalization is part of our scenario, and introducing advanced and resistance material with respect to the wear and so on. We are looking for, with respect to the future approaches, we are working on instrumentation and measurements a lot to control and process optimization. We have measurements while drilling. We have iShore, which is controlling the tunneling and mapping the tunnels and so. iDrill, which is a very smart one. Optimine and Automine, which is control all. And also we have some kind of Sanremo and ASRI control for our crusher. At the near future, it will be all in the one umbrella, under one umbrella, under the Automine system that we can control over that one. I think the others that you can read it. But as I said, that flexible circuit leverage ore variability to maximize resource utilization. So that's why we have to be flexible, and we have to use the heterogeneity of the material when we are designing our plant or our mining, and planning for the mining. And I think that's it. Finish. And just for your, this is kind of thing that I'm showing the mining engineer, the geologist, and the metallurgist. and that I was showing that you see that they have different ideas, they have different answers to this question, but the solution coming when we are working together. So we have to look at from the geology point of view to the end of the process and working together, not as a silos, different silos. So that's what well, I hope that you get something, and thank you for your kind attention. And if you have any question after, I can answer to that, of course. But I hope that was some kind of useful for you to understanding mining and mining industry and so on.